In our lesson on the conduction of semiconductors, we discussed how semiconductors are able to conduct electricity due to free electrons that break free from the covalent bonds of the atoms and create holes. These electrons then become free electrons that can conduct electricity, as in intrinsic semiconductors. We also saw how the effect of impurities can increase the conductivity of semiconductors, as in extrinsic semiconductors. In this lesson, we shall look at a type of extrinsic semiconductor called the N-type semiconductor. And at the end of this lesson, you should be able to explain how N-type semiconductors are created and how they conduct electricity. In extrinsic semiconductors, an element with more or few valence electrons is added in very small quantity to the semiconducting element like silicon or germanium. So let us use silicon to explain this. Silicon has 14 electrons with 4 in the outermost shell. Atoms are more stable when they have 8 electrons in their outermost shell, according to the octet electron arrangement. So this makes the silicon atoms to form covalent bonds by sharing their 4 electrons with 4 other silicon atoms. This way, each atom has 8 electrons in their outermost shell. When an atom with 5 valence electrons is added to this semiconducting element, it will introduce 5 extra electrons. 4 of the 5 electrons will form covalent bonds with 4 other silicon elements to complete their octet state, 8 electrons in the outermost shell, thereby leaving 1 free electron. This free electron will be free to move about in the compound that is formed. Examples of such elements that have 5 valence electrons are phosphorus, arsenic, and antimony. Each of these elements have atoms with 5 valence electrons, and they are called pentavalent impurities. When an atom of an element adds a free electron to a semiconductor, it is called a donor impurity. This implies in N-type semiconductors, there will be more electrons than holes to conduct electricity. So when the temperature of the semiconductor is increased, more free electrons are created in the compound by electrons breaking free from the covalent bonds and also creating holes in this process. When this semiconductor is connected to a source of electricity, these electrons and holes will flow in opposite directions to conduct this current. So let us summarize what we have learned in this lesson. We learned that extrinsic conductors are doped with what is called an impurity. When the impurity has an element that has 5 valence electrons, it is called an N-type semiconductor. And such impurities are called pentavalent or donor impurities. And in N-type semiconductors, electrons are the major charge carriers. So check out our subsequent lessons for another type of semiconductor. See you there.